We now turn our attention to solving applications of systems. In these problems, we're going to find them different than other types of application problems we've dealt with because these will have two unknowns that we need to determine. So we will assign two variables to those unknowns, and then we will write two equations that relate those two unknowns to create our system, then solve that system using substitution or addition. One of the types of problems that we're going to deal with are mixture applications. These arise when we combine two or more solutions to get a new solution. To show you a justification for the process that is involved in this application, I want you to consider this information that I'm providing. Most law enforcement agencies consider the following drinks equivalent for the purposes of calculating blood alcohol concentration. Those drinks are 1.5 ounces of an 80 proof liquor, 12 ounces of a regular beer, or 5 ounces of a table wine. Now you can think about, well, how are those equivalent, right? They're different amounts, but then also they have different percents of alcohol. So the way we determine that they are equivalent is we look at what is the pure alcohol in each of those drinks. And we find that by multiplying the amount times the strength of the alcohol. The 1.5 ounces of 40% alcohol then would have 1.5 times 0.40 or 0.6 ounces of pure alcohol. The 12 ounces of beer would have 12 times 0.05 or 0.6 ounces of pure alcohol. And then the 5 ounces of wine would be 5 times its strength, which is 12%, or 0.12, which is 0.6 ounces. So even though they are different amounts and different strengths alcohol, we see that they actually have the same alcohol content when we multiply the strength times this amount. So a person who consumes those three types of drinks consumes a total of 1.8 ounces of pure alcohol, not 18.5 ounces of alcohol. So this example illustrates that we multiply the amount of a substance by its strength to determine the amount of pure substance in the solution. So this is a problem that will arise from this type of application. Let's suppose that we have a metal alloy is 25% copper. Another alloy is 50% copper. How much of each alloy should be used to make 1,000 grams of an alloy that is 45% copper? So in these particular problems, I like to organize the information in a table or some type of graphic, which I will show you in just a minute. But that is, I want to list all the different solutions that we have. We have a 25% copper solution. We're combining with a 50% copper solution, and we want to get a 45% copper substance. And then we want to list what is the amount of each of those that we have. Well, we don't know, right? That's where our variables will come in. We don't know how much of the two we're mixing together, so X is going to represent the amount of the 25% copper, Y will represent the amount of the 50% copper, and we know that together we want to get 1,000 grams of the 45% copper. So to compare these, we have to look at what is the amount of pure copper in each of those substances. So this is where we write our strength. So we have a percentage that we're just going to convert to a decimal, which will be 0.25, 0.50, and 0.45. And then we multiply the strength and the amount together to get the amount of pure copper, right? So this last column is really the pure copper. So we would have 0.25 times X, 0.50 times Y, and then 0.45 times 1,000, which that we can simplify to be 450. So our equations will come in. There's two things that we know that relate these two things together. The amount of total copper, the pure copper, is related in the last column. And then the amount of alloys that we have is in the second column. So when we try to get a system, we're going to represent that by saying X plus Y equals 1,000, right? That's just a total alloy. And then 0.25X plus 0.50Y equals 0.545 times 1,000, or we already know that to be 450. And so now we can solve this system using either addition or substitution. If we want to use the addition method, we need to rewrite these so that we can get opposites as coefficients and clear the decimals from one of these equations. So I'm going to write it like this. We'll have X plus Y equals 1,000. And for the second equation, let's multiply by 100 so we can get rid of those decimals. And that would be 25X plus 50Y is equal to 45,000. So now we need to choose, do you want to eliminate X or do you want to eliminate Y? So I'll just choose to eliminate X. So we need to find what is a common number between 1 and 25, that is their coefficients. And that common number is 25. So remember, we need to have a 25X and a negative 25X as coefficients. Well, we already have the 25X on the second equation. To get a negative 25X in the first equation, we need to multiply the first equation by negative 25. So that would give us the new system, negative 25X minus 25Y is equal to negative 25,000. And then we keep the second equation the same. 25X plus 50Y equals 45,000. And now we can add the two equations in the system together to eliminate the X. So the first terms go to 0. Negative 25Y plus 50Y is just 25Y. And that equals negative 25,000 plus 45,000 is 20,000. And so when we divide each side by 25, we get that Y is equal to 800. And then to find X, we can substitute into the first equation. We know that X plus Y is equal to 1,000. So X plus 800 is equal to 1,000. Or subtracting 800 gives us X equals 200. So this means that we need to have the 200 grams of the 25% copper, and Y is 800 grams of the 50% copper to get a metal that has 45% copper.